Recording in progress.
Okay, Andy. Good morning, everyone. Online friends, can you hear my voice? Say yes or no to me once. Okay. So yesterday's notes I updated, but assignment question I not added. Not added. Assignment on inheritance. So I added one question here. Can cross check it. So this is the question. The question. So read that question and uh, draw one small layout. What information available? Draw one layout and convert that layout into code form. That's the assignment, right? Whatever the classes methods I given, you read it and draw one diagram for it, small layout, and convert that into code form. This is your question. Right. I added yesterday, I forget it to add anyway. So I'll go forward for today's class once. Yesterday I introduced generalization, but diagram not drawn for you. So generalization meaning is all the methods of parent class and overriding methods from child. I made a statement yesterday. This diagram I posted yesterday already. This is generalization. Parent class OB is equal to new child class. This one. Okay, right. Today's class is, let me draw one small diagrammatical form on generalization. The generalized object I want to show for today. I want to show that generalized object. Inheritance application 4. Parent class, child class, demo inheritance 4. This one. Our target is this. So whenever we write like this, in the background, what happens? I want to know. Anyway, definition I given here, but before reading this paragraph, let me draw one small diagram, small visual I want to diagram. So this document I added today. Anyway, yesterday I forget it, today I added. You try that. Anyway, within 2 days, I'll give the solution from inheritance and one program on references pending. These 2 programs I'll write on Saturday. That's the plan. So revision on references, revision on inheritance with the 2 assignment solutions. You try. Okay, right. That's the plan for this Saturday. Meanwhile, I'll be covering this inheritance. So execution flow of above program, nothing but demonstrating generalization process. So class files I'm keeping always common. P class dot class file and C class dot class file and here demo inheritance for dot class file and this is main class. Right. So method area where classes are loaded. Heap area where objects are created. Java stack area where methods are executed. Method area, heap area, Java stack area. The first method is main. Main method. In this main method, P class OP equal to new C class. Like this. Now your execution control will read this total line. It will read the total line. Total line will be detected. After detecting the total line, it will understand. I must do generalization process. Generalization process means I must create one object. How? New child class means create object for child only. But at the ending, the object must look like a parent because address is on parent. No, right. So object creation is for child, but internally generated as a parent object. That's the meaning actually. So new child means load parent class, parent class will be loaded first. This parent class is having methods M1, M2, M1 of X, M2 of Y. Two methods are there, no? M1, M2. They are all, the two are instance methods. Then child class is loaded. Child class is loaded. In this child class, we had M1 of X, M3 of Z. Like this. These two objects, these two classes looks like a single class only. Once the loading has been completed, object creation starts. The object creation is generalized object. The meaning, take all the methods from parent. So, M1 method will come from parent. Void M1 of int X. And the M2 method you take it. Void M2 of int Y. Generalized object means it takes all the methods from parent first, because here address location is parent, no? Yes or no? Na? But you started creating object for child. So what it will do now? Your internal algorithm will look for overriding methods here. Among these two methods, which one is overriding now? M1. So it takes M1 and replaces. It takes M1 and replaces. Void M1 of int X. It replaces. Now, what about this method, sir? This method will not come. I'll have understood this. That is called generalized. Generalized means all methods from parent, from child, we take only overriding, we'll take. So that overriding method will come and replace the parent in the object. So this one, we call it as generalized object. Sir, why we are doing like this? This generalization process is used to control child classes. Sir, how you are controlling child class? You are controlling child class to have only overriding methods. If you take non-overriding methods, they will not come. Means you are controlling the child class to have only overriding methods. Non-overriding methods will not come. General students will ask, sir, if I want non-overriding method, they'll ask a question. Non-overriding method means take normal inheritance. You have to take it. If you want all methods, normal inheritance. No, sir, I want to only overriding methods from child class means you have to take a generalization process. Why I drawn this diagram means to educate you from child class only, overriding coming, non-overriding not coming. This is generalized. I can access OB dot M1, no error. OB dot M1, no error. Here. No error. Error will not come. OB dot M2, error will not come. Whenever I say OB dot M3, error will come. OB dot M3 of 13, error will come. Why error means the method not available there. It is not available in the OB or not now. Compiler only will give the error. Right. All of you understood generalized object. Right. Normal object is there. Generalized object is there. Normal inherited object means all methods will be there. Generalized object means only overriding methods from child will be there. That's the point. So I'll paste here. I'll make one statement. Make it note. What is this disturbance? Headache is coming. Right. Generalization process is used to control child classes. Generalization process is used to control child classes. To control child classes having only overriding methods. Generalization process is used to control child classes having only overriding methods. If we write non-overriding also, they will not come. So it's override. So two objects are popular, normal objects and generalized objects. Specialized objects are different training. That is different. Okay, right. All of you clear about two syntaxes what I drawn yesterday to you, right? This one. Two diagrams are there. This one separate training. You have to wait it. Last training will be there. This one. For this, I made a statement now here. Cloning, serialization. The two processes are last. Can you see here? Cloning, serialization. 9th and 10th levels of your object oriented. Last level. In the last level is that only this one. The two will come in the last. Until then, two processes you should remember. Normal object creation and generalized object creation. Generalized means only overriding methods from child class. All of it clear up to here? Right, okay. Now, up to now, we are working with methods. That is case 1. Variables and methods from the parent class. Only case 1 we worked or not now? Now we go with the case 2. Sir, variables methods over. Now we are going for constructors we are working. So constructors from the parent class or superclass. Case 2. Constructors from the parent class or superclass. Parent class or superclass. Here two cases will be there. Zero parameter constructor from the parent class and courses. Right. Now zero parameter from the parent class actually. Suppose if you have zero parameter, what happens? See there. Look here once. I'm taking one program now. Inheritance application 5. Inheritance application 5. I'm taking. Packages. Again, I am taking P1 and P2. I am taking. Same. Under P1, you have a class. Always I'll take P class. I'm taking. Under P1, I'll take one class as C class. Now C class extends from P class. C class extends from P class. So constructor means having the same name of the class, no? Constructor means having the same name of the class. So here I am taking zero parameter constructor. I am taking one zero parameter constructor. Now system dot out dot println here. Zero parameter. You can say parent class zero parameter constructor. You can say message, small message. I am taking one constructor from the child. Here. System dot out dot println. Here. Child class zero parameter constructor. Child class zero parameter constructor. I had one constructor in the parent. I had one constructor in the child. Now, in the normal inheritance process, under P2, main class, demo inheritance 5. Demo inheritance 5 here. In this demo inheritance 5 here, import p1 dot star. Here I am creating object for child class OB equal to new child class. Now here child class constructor call is available. Now this is child class constructor call, no? Yes or no? Na? Right. Sir, this is one child class constructor call. We are not calling the constructor from the parent. We are not calling constructor from the parent. As a code writer, we people not calling the constructor. Constructor call means while object creation only. While object creation, I am calling the constructor from the child only. I am not calling from the parent. But if I run it, parent class constructor also will come. Sir, how this parent class constructor came, sir? Because we not called, no. Constructor is a method. It should be called. Whenever it calls only, the method should come. Constructor also, whenever it calls only, the constructor will come. Sir, without calling, how parent class constructor is coming? It's an interesting question for you. So what happened means, compiler at the compilation stage, for the child class constructor, it will add one super of here. It's going to add it. Automatically it adds one super of. The super of is the constructor call it is. So this child class constructor will call parent class constructor by using what keyword now? Super of. Who added this super of means compiler will add it. Who will add it now? Compiler will add it. That's the statement now. Now the statement is when we have zero parameter constructor, when we have zero parameter constructor, when we have zero parameter constructor in parent class, when we have zero parameter constructor in parent class, then compiler at compilation stage, when we have zero parameter constructor in parent class, then compiler at compilation stage will add super of, to the child class constructor, and which is parent class constructor call. When we have zero parameter constructor in parent class, then compiler at compilation stage will add super of. Then the compiler at compilation stage will add super of to the child class constructor, and which is parent class constructor call. The super of is nothing but parent class constructor call it is. So compiler is going to add that super of. That's the meaning. So when there is zero parameter constructor in parent, when there is zero parameter constructor in child, both are executed. The child class constructor will call parent class constructor internally by using super of, which is added by the compiler for zero parameter constructor. That's the meaning. So here, the same short program I'll paste here. pclass.java, class.java, p2 demo inheritance, 5 dot Java. This is one main class. Suppose if I have parameterized constructor, sir, make it. Parameterized constructor in parameterized constructor from parent class or a super class. Parameterized constructor from parent class or super class. If it is a parameterized constructor, we must add it. The super of is added by us. If it is a parameterized constructor, we should add it. When we have parameterized constructor, in parent class, then we must add. Then we must means developer. We must add super of to the child class constructor. When we have parameterized constructor in P class, parent class, then we must add super of to the child class constructor to pass parameters. To parent class constructor. When we have parameterized constructor in parent class, then we must add super of to the child class constructor to pass parameters to parent class constructor. In the first case, super of is added by the compiler. In second case, we are adding the super of. That's the meaning. So whenever you want to pass parameter to parent, we only will add a super of and pass it. See there. Same program, I'll pass parameter here. Inheritance application 6 I'll take. Inheritance application 6 I am taking. Previous program I'll copy it. P1, P2 I'll copy it. I changed the name. Right. So parent class constructor, child class constructor, and main class. In parent class constructor, I am passing one parameter here. Now parent class parameterized constructor. So system.out.println. The value x is equal to plus x. So for parent class constructor, we have to pass parameter, but here child class constructor is there. I am passing value to child class constructor, but the value should go to parent class constructor. But this is child class constructor call. So the parameter will come here. Int v, value, nothing but. This parameterized constructor available in the parent, we are going to call through child. The child class constructor will take the value. This value given here. So here, this is parent class constructor call with the parameters. We are only giving the value or not now. Now the child class will give the value to parent class. Parent class answer will come. We observe this, right? The finally, what I'm trying is, you can have zero parameter constructor in the parent. You can have parameterized constructor in the parent. Whenever zero parameter constructor, compiler will add super off. If it is a parameterized constructor, we must add super off to pass the parameter. That only difference. Why we must use super off means, while object creation we had child class constructor call is there, but parent class constructor call not available. So super off is a built-in form to call parent class constructor. That's a theory. So the answer is coming from parent class parameterized constructor. The answer is coming. So same names taken, no difference. Here, demonstrates. Finally, the constructors from the parent class executed. All of understood this theoretical statement? Yes or no? Na? So constructors from the parent class executed. But if it is a zero parameter constructor, super off is added by the compiler. If it is parameterized constructor, super off is added by the programmer. It's a theory. Now, as if like method overriding above. You had method overriding no here, method overriding. Here, method overriding. So can we do constructor overriding or not? That's the entire question. Make it FAQ. Define constructor overriding process. Define constructor overriding process. Right. What is the rules of overriding process? Sir, return type must be same. Method name must be same. Parameter list must be same. Parameter type also must be same. Then only we can perform overriding. But whenever we take parent-child relation here, whenever we take one parent-child relation here, if I take P class, one class here, C class, one class here, we are having one extends anyway. Parent class constructor will have parent class name. Child class constructor will have child class name. Yes or no? Now, parent class constructor, parent class name, child class constructor, child class name. So methods are not same. The names are not same, no? When the names are not same, constructor overriding possible or not possible? Louder. Not possible. So constructor overriding not available. If anybody asks to define constructor overriding, the answer, make it. There is no concept of constructor overriding process. there is no concept of constructor overriding process because parent class constructor will have parent class name and child class constructor will have child class name. So when the names are different, overriding not possible. Static method overriding not available. Constructor overriding also not available. Only instance method overriding is available. That's the meaning. So there is no concept of constructor overriding process because parent class constructor will have parent class name and child class constructor will have child class name. All have understood this statement, right? This is about your constructor. Suppose if I have blocks, what happens, sir? Case 3, blocks. Blocks. Blocks from parent class, or you can say super class, you can say. Right. Now I am taking some blocks here. Inheritance application 7. I am taking. Inheritance application 7. Under P1 again I am taking the class as P class. C class I am taking. Under P class, I'll take one block. That is one static block I'll take. I'll take one instance block I'll take. So system.out.println parent class static block. Parent class instance block. Child class extends from parent class. Here also one static block, one instance block. Here child class static block. Here child class instance block. Instance block is there. This is parent class, this is child class. When these two classes loaded, the two classes will look like a single class. Yes or no? Na? So whenever two classes loaded, when they are loaded into method area, parent class one static block, parent class one instance block, child class one static block, and child class one instance block. Both are looking like a single class only. If both are looking like a single class, static blocks will have highest priority, instance block will have highest priority. Static block should come first, class level first, then object level. Okay, right. Now I'll create one normal object. Inheritance means object creation. So under P2, demo, inheritance 7. Inheritance 7. I'm taking. So import P1 dot star. So here, child class OB equal to new child class. I am creating object. So whenever I create an object for child class, parent class loaded, child class loaded, and both are referred. So first who came now? Static blocks has the highest priority or not? If it is a single class now, who will have highest priority now? Static block. Then only instance blocks are not now. If there are blocks in the parent class and child class, then the statements, static blocks from parent and child classes are executed first, and then instance blocks from parent and child classes are executed. Make a statement. In normal inheritance process, static blocks from parent class and child class are executed first, and then instance blocks are executed, and then instance blocks are executed. In normal inheritance process, static blocks from parent class and child class are executed first, and then instance blocks are executed. Simply you can say static blocks from parent means parent child first and then instance blocks. Why means internal execution behavior both looks like a single class only, so they are accessing both. Same names I am taking. So method overloading, that is instance method overloading, constructor overloading, not available. Static method overloading, not available. Blocks overloading, overriding. Blocks overriding, not possible now. We don't have a concept of blocks overriding. We don't have it. Right. This is theoretical. Blocks in the right. All of understood this theoretical aspect? What he said? Okay. Look here. Okay. I also shake the head. He also shake the head. That if anything I need, I'll call it. Maybe he's seen the call now, I think. Okay. Look here. All of you understood, no? This is theoretical. Actually, methods only important because I given more time on variable and method. I given more time. Constructors and blocks. If I have constructors, super off will be there. Zero parameter constructor, compiler will add super off to the child class constructor, and if it is parameterized constructor, developer should add super off to the child class constructor. That you remember for interview. Blocks is a optional question to you. Okay, right. This is a point. So whenever we are writing notes on method overriding, they will ask method overloading. They'll ask, make it FAQ. Define method overloading process. Method overloading process. More than one method with the same method name. More than one method with the same method name, but differentiated by their parameter list or parameter type. More than one method with the same method name, but differentiated by their parameter list or parameter type is known as method overloading process. More than one method with the same method name, but differentiated by their parameter list or parameter type is known as method overloading process. Method overloading process. Look here. In method overloading process, return type of methods are not considered. In your overriding, return type must be same. That is the rule. But here, there is no rule about return type. The methods can be return type or non-return type. They are not included in the overloading process. The statement here, second point. Return type of methods. Return type of methods are not included, if not are not considered in overloading process. Not considered in overloading process. Return type of methods are not considered in overloading process. The meaning, return types can be same or different. The point. Right. To perform method overloading process, inheritance is not mandatory. Actually, overloading topic not belongs to inheritance chapter actually. It belongs to polymorphism chapter. But in all the books and materials, we'll write overloading in the inheritance. The reason, name similarity. Overriding, overloading. They'll ask a question always. So in the process of giving training to a student, always we'll write overloading with overriding. But to perform overloading process, inheritance is not mandatory. We can perform with single independent class also. You can do overloading. Make a statement, note. For overriding, inheritance is mandatory. For overloading, inheritance is not mandatory. Make a statement, note. To perform method overloading process. To perform method overloading process, inheritance is not needed. inheritance is not needed. Inheritance not needed actually. To perform method overloading process, inheritance is not needed, which means we can perform method overloading process. We can perform method overloading process using single class also. We can perform method overloading process using single class also. You can do with single class also. Right. This method overloading process supported by instance methods, static methods, and constructors all are available. Instance method overloading is there. Constructor overloading is there. Static method overloading is there. All make it. We can perform overloading process on instance methods, static methods, and constructors. You can do all on all you can perform overloading. We can perform overloading process on instance methods, static methods, and constructors. You can perform. Now let me take examples one by one. Let us do instance method overloading once. So example 1, instance method overloading process. Instance method overloading process. Right, see there. Again, I am taking inheritance application 8. Package P1 and so P class I am taking, parent class, C class I am taking, here I am taking a method anyway. So public void M of int A I am taking. Public void M of int A comma int B. This is overriding methods. Method with the same name but difference in their parameter list or type. You can take it. This is overloaded methods from P class. In the child class, I'll take 2 overloaded methods here. Public void M of int A comma int B comma int C. I am taking. So public void M of int A comma int b comma int c comma int d. Sir, this is overloaded. Method with the same name but difference in the parameter. So this m is overloaded method. Here m is overloaded method. Suppose under P2, I'll go for class demo. Inheritance 8. P1 dot star. Like this. Now here, I'll create object for normal inheritance process. Child class OB is equal to new child class. If I say OB dot m, it should be extends, no? Because the reflection did not came. Now, OB dot m, can you see 4 methods are there, no? These 4 methods are overloaded methods. In the object level, there are 4 methods available with the same name, but difference in their parameter list is known as overloaded methods. You can call any one method. If you want to call one method, you can call any one method. If I call this method with 2 parameters, 2 parameter method will run. If I want to call one 4 parameter method, 4 parameter method will run. Like this. No, sir. I want to call all methods at a time. So calling all methods at a time means some interlinking needed. Means you must call one method and that method should call another method and the method should call another method. Like this, you can call it. Suppose I am calling one method here. I am calling one method with 4 parameters I am calling. So which method is called means this method is called. So 4 parameter method. This method will print the D value here. There 4 parameters are coming, it prints D. Now remaining 3 parameters, it has to give to this method. Whenever we want to access, whenever we want to interlink 2 methods from the same class, we use a keyword known as this. What is it now? This dot m of a comma b comma c. Already you know this means referring the same object only, no, anyway. So m method calling this m method from the same object and passing a, b, c. Now this method will print C value here. And it want to give AB for the parent method. It want to give AB for the parent because extends keyword P class is the parent or not now. Parent means we use what keyword now? Super dot M of A. Super of is a constructor call. Super is a method call. Super means method call. Super of means constructor call. Difference is there. All of you understand? So super brace is there means constructor. Only super is there means method. This is method call. So we are calling the method from the parent. Whenever you want to call the method from the same class, this. Whenever you want to call the method from the parent class, super. Now control will go to here. So system dot out dot println printing b value here. Now send that a to here. We will send with super of this dot m of a. So finally the control will come here. System dot out dot println a plus a. Now see which one is executed first now. Whenever I call this method will call this method. This method will call this method. This method will call this one. Means first answer A will come, next B will come, next C will come, next D will come, because internally the methods are interlinked. Have you understood now? Right. So method overloading, instance method overloading is possible. And we had two keywords known as what now? Super and this. Super and this keywords are used to access the members from the same class or parent class. The notes is like this. First, instance method overloading possible. Loading possible. P1 parent class dot Java. P1 child class dot Java. P2 demo inheritance 8 dot Java, the main class. Sir, in this program we have been introduced with two keywords. FAQ. What is the difference between this and super? Right. This keyword is used to access the variables and methods from the same class, or you can say current running class. This is used to access variable also. Already you know, no, this dot A is equal to A, this dot B is equal to B, you are accessing. Super keyword is used to access the variables and methods from the parent class in inheritance process. If inheritance process is there, super will work. Inheritance process not there means super will not work. Only in inheritance process we are going to use super. Right. Hope you got information about this and super. Okay. So complete it. Right. Now see. I'll go for example 2. Static method overloading process. Static method overloading process. Whenever we have instance method of overloading, static method also possible. Okay, right. So same program, I'll convert the methods into static. Whether this keywords will work or not, we are going to cross check. Right. Now, inheritance application 9 I will take. Inheritance application 9 I'm taking. Right. See there. Instead of instance, I am making it as static. This one, I'm making it as static. I made this method as a static. I made this method as a static. I made this method as a static. Whenever I made the method as static, that super, these keywords are getting errors. Why means super and this are non-static reference variables, non-static variables they are. So non-static variable you cannot use in the static, that only. Cannot use super in static context. So this is not available. You cannot use this in the static constant. Not available. You cannot use this in the static context. Not available. So static method calling another static method not there by using super and these keywords. The reason super and these keywords are non-static variables there, non-static reference variables, right? Then I will print it, sir, means I'll print completely, I'll print here. Okay, this is okay. Parent class M of A. Because I have to print completely, no? Printing completely. like this. I written all this. So how to call these methods? Sir, if I want to use this and super, where I must use? This and super you cannot use inside the static. Anyway, static method overloading possible. This is static method. This is static method. Difference in the parameter means overloading is coming. But you cannot declare super and this keyword inside the static method because super and this keywords are non-static variables. Sir, if I want to access static methods by using this or super, how I should access? Means you can take one non-static method you can take. You can take one non-static method you can take. One instance method. Using this instance method, you can call it. I will call it now super.m. Super.m. You can call it. Super.m. You can call it. This dot m. You can call it. This dot m. You can call it. So if you want to use super and this keywords, you must use in the instance method only. You can use it. So overloading possible. You cannot use this and super keyword. If you want to use, you must use in the instance method. Go to the main class, create object, call the method. I will call now ob.access. You can call it 11, 12, 13 and 14. If I call this method, all will come. P class, C class, all are coming or not now, right? Only difference is static method overloading possible. But you cannot declare super and this keywords inside the static method because the keywords are non-static variables. If you want to access static method by using super and this keyword, they must be used in the instance methods. Not only information here. So static method overload possible. First point is it is possible. So it is possible. Some points I'm writing, some review points I'm writing. So undoubtedly we can perform static method overloading process. We can perform static method overloading process. We can perform static method overloading process. We can perform. We can perform static method overloading process. We cannot declare this and super keywords in static methods. Static methods. Because this and super are non-static reference variables. So non-static you cannot use in the static, no? It is error. We can access static methods. We can access static methods using this and we can access static methods using this and super keywords. But these keywords must be used in instance methods. Must be used in instance methods. Must be used in instance methods. We can access static methods using this and super keywords. But these keywords must be used in instance methods. You cannot use in static methods. Right. All of you understood up to now? Theoretical, total theoretical only today. One is constructor. Constructor. So constructors from the parent class and superclass. When there is one zero parameter constructor in the parent class, compiler at compilation stage will add one super of to the child class constructor, one super of to the child class constructor, which is parent class constructor call. When there is one parameterized constructor in the parent class, developer means we people must add super of to the child class constructor to pass parameters. That is this one. So constructor overloading not possible because we cannot have same constructor names in parent class and child class. Parent class constructor will have parent class name and child class constructor will have child class name. We cannot have same names, so it is not possible. So blocks from parent class. When there are some static blocks and instance blocks from parent and child, static blocks will have highest priority in execution than instance blocks. This is normal. Method overloading is an extra concept added to this chapter. More than one method with the same method name, but difference in their parameter list or type, we call it as method overload. This method overloading, in method overloading, return type is not included or not considered. You can perform overloading with static methods, instance methods, constructor. Constructor overloading is pending at one program. Okay, right. Similar coming now, you stopped it. Okay, right. So you can perform overloading with instance methods, static methods, and constructors. You can do. If you want to perform overloading, inheritance is not mandatory. You can do with one single independent class also. You can do the information. Then I started writing your programs and I introduced this and super keywords. I started introducing. In interview, they'll ask together. So they'll ask together this and this of super and super of. Super of came, this came, super came, this not entered. So this will come by the next program. It will come. So today you understood super and super of you understood. Super is a keyword is used to access variable and method from parent in inheritance process only. Inheritance process not there means super keyword will not work. Super of brace is there no. This is method. This is method call actually. Super off means calling the constructor from the parent class. That also in inheritance process only. It's a theory. So I can use this keyword to access method from the same class. I can use super keyword to access method from parent class. If I declare this and super keyword inside the static method, error will come because the two are instance variables are non-static variables. Non-static variable you cannot use inside the static method, error. But you can access static method by using super and this keywords by declaring these keywords in the instance methods. The theory for today. Okay, right. So these are the points for today. Theoretical points. I added one document for inheritance. Try that for assignment today. And tomorrow's class will be one last program. You had it. Example 3 is constructor overloading process. Constructor overloading process. You had it. That's for tomorrow. Right. I'll have understood today's class. Right. Take a break. I'll upload the notes now. Right. Thank you very much for today.
Kepanjangan.